In this video, we'll be talking about the converse of the Pythagorean theorem and some cool things that follow from it. So first of all, let's take a look at a triangle and make sure it's a right triangle. If we have a right triangle, we know that the Pythagorean states that a squared plus b squared is equal to c squared, where a and b are just the lengths of two legs and c is our hypotenuse. Now, what is the converse of this theorem? Well, the converse of this theorem tells us that if this is not true, then the triangle is not right. But if it is true, the triangle is right. So, for example, okay, so here we have something that looks kind of like a right triangle, but we cannot assume it's a right triangle unless we see the angle marker here, but we don't. So we actually have to test this out. And that's where the converse of the Pythagorean theorem comes about. So if this is in fact a right triangle, then a squared plus b squared should be equal to c squared. Now what should we use as our hypotenuse? Even though this looks like our hypotenuse, you have to have a more substantial reason to use this as your c. And the reason that you should really use is the fact that the hypotenuse, the c, should be the largest side. And in this case, it is in fact the largest side. So if this is in fact a right triangle, then that would be our c. So let's use that. Oh, let's make that actually not 5. I want this to be a little harder. Let's make it 5.9. All right, so now we really don't know if it's a right triangle or not. All right, so 3 squared plus 4.6 squared equals 5.9 squared. Well, we don't know if that's true, but we're going to test that out right now. On the left side, when we work that through, we should get approximately 30.16. And on the right side, when we figure that out, we should get approximately 34.81. Well, obviously, this is not true. And if they feature that screenshot on YouTube, everybody will think I'm crazy. Because 30.16 is not 34.81, which means that this is not a right triangle. And that's how the converse of the Pythagorean theorem works. If they were in fact equal, then you would know that it is a right triangle. All right, but I promised you to show you 2 more cool things that follow from the converse of the Pythagorean theorem. And it's the fact that we can not only tell whether or not the triangle is right, we can tell if it's acute or obtuse. So in this case, we have 34.81, so the would-be hypotenuse is larger than it should have been for a right triangle. So really and truly, if this were drawn to scale, it would have looked more like that with a fake long hypotenuse. It's not really a hypotenuse, but it kind of looks like one, but it's just larger than a hypotenuse, which means that this triangle, since our fake hypotenuse is longer than it should be, this is actually an obtuse triangle. If it had worked the other way around, let's look at an example. If it had worked the other way around, then the triangle would be acute. Let's look at an example. All right, so let's pretend for a moment that we don't know what type of triangle this will be, and we're trying to find it out. We would want to use the converse of our Pythagorean theorem to see what type of triangle this is. So if it were right, then, well, what's our longest side here? Our longest side is 10, so that will serve as our c, or maybe hypotenuse. So we'll see how that works out. A squared plus b squared should be equal to c squared if it's a right triangle. And, well, let's see, 7 squared plus 8 squared then should be equal to 10 squared. Again, only if it's a right triangle. So when we do the left side, we get 113, clearly not equal to 100, which is what you get when you do the right side. Now, this 100 is our, our fake hypotenuse. It's smaller than it should be, which means the triangle actually looks, let's try this again. So if this is a right triangle, oh wow, that's lovely. This, with our small 100, would close in a little bit and look like this. So that means that our triangle is acute. So if that thing that should be the hypotenuse is smaller than the other side, the triangle is acute. But if it's larger than what's on the other side, so if our c squared is larger than what's on the other side, then it's obtuse. Okay, so what we just spoke about is called the Pythagorean Inequality Theorem, and here it is in writing. I just wanted to make sure you have it down in your notes.